Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. Today, we have the unhappy task of needing to do some volume texture debugging, which is going to be long and arduous. I'll just get right to the heart of it. Basically, anytime you use a GPU to do anything, it is unpleasant, and today is no exception. I don't feel like I feel like this monitor has gone into some kind of a weird mode. I'm gonna see if I can fix it. It's in like a weird color mode where everything looks like, you know what I'm talking about, where they the monitor manufacturer is helping you get a good picture, quote unquote, by having some really ridiculous sort of filtering or color balance that's happening that's really bad, and it makes everything look messed up. So I think that's what's happening here. And there we go. Standard mode looks pretty good. Standard mode. Yes. All right, that's actually much better. I think it was on game mode before. I don't know what that was supposed to do, but it made everything look pink and weird. All right, so let's go ahead and you couldn't see that because, of course, you're just seeing the raw HDMI feed, which probably looks normal. I was seeing this weird, really strange, sort of hyper contrasty mode. I don't know what was going on there. Anyway, so what we have to do today is we have to figure out why we can't. The thing that we were trying to do on the GPU was actually really simple, right? All we're trying to do is look up in a voxel and traverse a linked list. Okay, it's something that's incredibly simple. We've even basically done this exact thing on Handmade Hero before on the CPU, and on the CPU, of course, it took no time at all to get it working, and we've done a bunch of more advanced things on the CPU side. On the GPU side, even something as basic as storing a three-dimensional array with a pointer to a linked list is incredibly arduous. It takes days to get something like that working typically. And the reason for that is that, first of all, the APIs are horrid, right? They're just absolutely abhorrent. Even relatively modern ones are awful. They are not designed even close to as well as a modern CPU ISA. Modern CPU ISAs are obviously better, but GPUs don't even have ISAs that you can program to directly unless you go with only a specific GPU. So you're forced to go through a committee designed API that's generally just absolutely awful. In all ways it can be awful, it is awful. And then you stack on top of that the fact that the GPU itself usually offers either minimal or no debugging features. So you also lose that ability. So not only is your program extremely mysterious to you, because, for example, you saw last week how specifying GL_red versus GL_red_integer made a huge difference in whether or not something worked. Right? Now that just makes no sense, right? That's not something that we would ever put up with in day-to-day CPU programming. I mean, unless maybe you're into web programming or something. But that's par for the course on GPU programming. Somebody made a random API, they didn't think it through particularly well, and you just have to deal with all of its ridiculousness and things that you don't necessarily know, but that they thought were a good idea, but that weren't a good idea. You just have to learn and deal with, right? It's really crappy and unfortunate. It's why I don't like programming on GPUs. And I wish they would just kind of go away eventually, but that hasn't materialized. Anyway. So that's where we're at. We are trying to send down a volume texture. A volume texture obviously is a texture that has 3 dimensions to it, so it can be indexed with 3 variables, x, y, and z. And we have a shader that's attempting to look up into those. Now, I wanted to start today by doing something relatively simple. I wanted to start today by just using structured art to verify using Nsight, which gives us some limited debugging capability. I wanted to verify that we could get the texture transmitted properly. And what I mean by this is, we've talked about this on Handmade Hero before. Structured art is a concept that is used all throughout the pipeline in game development, not just in GPU land. But it means that instead of using your actual assets that you're trying to debug and your actual output, you instead force a very regular pattern through the output, which allows you, when you look at the results, to quickly see whether they're correct or not. And so what I'd like to do is, I'd just like to start today pushing a little bit of that so that we can verify some basic things about what's going on with our code without having to be so sort of like finicky and tweaky when we're using the debugger. So what I want to do here is I want to have a way of taking the volume texture that we're submitting, and I want to be able to fill it with a pattern that I could immediately recognize was the correct pattern without having to really scrutinize the values that are in that pattern. So what I'm going to do here is, if you take a look at when we're going through the element index here, which you can see what we're doing right now is we pack into our lookup texels. We're just packing constantly exactly the index of the first like link, if you will, in the linked list that starts at this voxel. So, you know, what we expect to see in our voxel is zeros everywhere there are no light sources, and not light sources, but lighting elements that have been computed. We expect to see 0 everywhere that is true, and then we expect to see a single value anywhere there would have been a lighting element, and that value indexes into an array of values that we then follow as a chain to pull out all of the lighting elements that were relevant to that voxel. Okay, so that's what we expect to see. Now that's kind of hard to verify because it basically means that we just have a sea of zeros with some random numbers stuck in them, and we have no way of really knowing how correct that was. And furthermore, when we go to do the voxel lookup in the shader, we have no way of knowing what that should be either. So what I'm going to try to do here is I'm going to try to do something a little bit different. I'm going to try to pack a value in here that will actually be easier to inspect and give us some ability to figure out what we are looking at. Okay. So the first thing I'm going to do is we're going to take a look at how we're packing here. And instead of allowing this to be the final pack, because that actually produces what we would believe are the correct results, instead I'm going to go through and I'm going to pack something different in here. And the way I'm going to pack something different is I'm basically going to mimic what we were doing here, where we step through the voxel like so. You can see here we've got sort of a thing that looks up into the voxel. I'm just going to copy those loops in here. And you can see what these loops are doing. These loops are just going over the different dimensions of the voxel, z, y, and x. And they're going through every node in the voxel. So when I come in here, I'm referencing every node in sequence of this voxel. So what I could do is in here, I can just place, if I want to, I could literally place just a running counter. So I could put a U16 in here that's a counter. And what I can do is every time through, I can just assign the counter value that's in this location to a monotonically increasing value, so that if I were to look at the voxel, I should just, in memory of this voxel, just see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to the limit of a U16, which is 65535. And when I would get to 65536, I should see that counter wrap back to 0, because it's a U16. So I see it go like 0 through 65535. I should then see 0 start again, 0, 1, 2, 3, 4, 5, 6, right? That's what I should be seeing. And so let me just grab out where that is. That's dest in here, I guess. Yeah, it's in dest. So let me just grab that out. I also should remove, since we now have the integer version working, I should remove the lookup f texture and get that out of here. Okay. I also need to get it out of here. There we go. Okay. So now if I run this program, in theory, nothing in particular should happen here. We should get the same output as we did before, and we roughly do. Of course, we do have a problem now, which is that our shader will be faulting all over the place, effectively. I don't know if we get any reports of that. I don't think we really do, no. And so that may create problems for the debugging. So what I want to do also is change the shader so that we're not trying to look up off of these values that will index into the middle of nowhere off the bounds of an array. So I'm just going to pop over to the OpenGL side of things, and I'm going to take a look at the shader here in the ZBias shader. And I just want to go ahead and get rid of the thing where we actually look it up. And instead, I want to use that value just directly. So when we look up this lighting value into the voxel here, you can see we're producing an integer. Instead of doing any of this, right, where we're ever looking it up, like this texel fetch stuff or any of this stuff, I don't want to do any of that. Instead, what I want to do, oh, and it looks like I already ifed it out here, so I guess our shader isn't really doing anything bad. Instead of doing that, what I want to do is I want to take that value that I got out, and I want to set the use light color to basically be representative of what that value was. So what I'd like to do is say use light R equals, you know, whatever this light index is divided by 65535, right? So I can do a divide here and get a value from 0 to 1. And furthermore, I could do just a replication of that as well. So I can, you know, I believe you can do a shorthand in shader syntax. I believe you can just do like a shorthand for replication, but I'm not going to try to do that because I always forget how the shaders do their crazy Swizzle nomenclature, and I don't want to mess it up. So I'm just literally doing an assignment like you would in C instead. All right, so if I run this now, I would actually kind of expect to see something different here if I didn't mess it up. I would expect to see things sort of shaded according to where they are in the voxel grid, if that makes sense. You know, it actually looks like it's kind of busted, right? Like, I don't know where we are right here, but we're kind of in some kind of a weird, like, non-functional state, and I'm not sure why. Oh, right. I forgot. We're still doing output texture debug, which we really don't want to do, because that's going to now crawl this bogus array. Let me quickly nerf that. Because again, we are no longer sending down a voxel that can actually be used for the purposes of traversing the linked lists. It's just got stuffed values in there, so I can't ever do anything with it that would require me to have a valid list there, right? That's not on the table. All right. So this is interesting to see, right? I see nothing after this happens, which is not even remotely what I would expect, right? So that's already kind of telling me something. Whoa. Don't ask me what that was, Visual Studio. So I don't know why I'm seeing this. So already things are kind of a little bit weird, right? What I would like to do is take a look at and see now if I can see that voxel, at least what its values are. And I'm also just a little bit weirded out. It could be just that, oh, you know what? It's probably because when I do output texture debug, it's probably because we've cleared out what was there. And so it's overriding, right? Like whatever we were rendering before is not getting rendered now. So that may be most of the problem, right? Like it may be that we can't actually do it that way. And yeah, so here's another thing we could do, for example. Let's suppose we left this in here so it can create it, and let's suppose that we just stuff the voxel like, uh, well, we can't really stuff the voxel after the fact, can we? Well, so what we can do is we could make it so that our lookup sort of used a different thing for the push lighting, right? We could be ridiculous here and do something like, well, okay, like when we go to send this down, we'll actually send down a different one than the one that we actually are going to use ourselves. We could do it that way. I don't really love that idea, though. What I would rather do is just not... I would rather just not have this be happening and leave the other thing. So, yeah, maybe the best way to do this so that we don't get into any more hot water here is when we're in here doing show lighting like this, maybe we just keep going through the old path, right? So when you press F1, you do this, and we never do output lighting itself. So we skipped this, you know, this path is just not a thing for the moment. So it'll keep on running the game exactly as it would. It'll still render just what we're seeing right here, just with the lighting textures having done their computation, right? So you can see we're still getting black, which I don't super understand, right? But we kind of expected something to be wrong because if this went correctly, that doesn't help us find our bugs. Because we know we've got bugs because our algorithm was not working on the GPU. So something's wrong with it. All right, so if we want to capture a frame here, I don't really remember what the key... There's a keyboard... there is some way you can capture a keyboard with... capture a frame with Nsight. Well, this is in Unity. I don't know if that's actually... Here we go. I'm like, I don't know if Unity's stuff is actually going to be the same. I would assume it would be, but let's find out. So let's see here. I want to know... That is what we were doing currently. I just wanted to know if you got a hotkey on that. So I wonder if the hotkey that's listed under pause and capture frame, if you could bind something to that, or if it's like... I feel like there should be one, right? There should be one that's when you do start graphics debugging. I feel like there should be a hotkey here, right? And Control Z does launch the HUD, but I don't really want the HUD. I guess it doesn't matter. I can just do that. It's no big deal. All right. So, wow, that captured a lot more quickly. I don't know why, but it certainly did. Anyway, so taking a look here, what I want to do is I want to see in the fragment shader, I want to see what the lookup sampler had for memory, right? And this is that 16-bit per entry 3D texture. So if I take a look at the memory of that texture, this is what I'm seeing, right? So I don't understand why it's all black. I don't know why that would be. So that's really the first thing that I want to figure out, right? Because I tried to stuff values into it. Obviously, I didn't succeed. I don't know why. And so I'm going to try to figure out why. All right. So let's take a look at what is happening if I break in the debugger at the point where I submit the texture. Let's just do the basic due diligence to verify that Of course, I don't know why my OpenGL thing isn't up here, but I guess we haven't stepped into it yet. But anyway, I'm going to step into push lighting. Oh, you know what? I may have forgotten to run the push lighting. Let's make sure I did that. There's the push lighting. Here's the pause and capture frame. All right. So now, let me verify. Okay, there we go. So I wasn't making that mistake. It turns out it was actually fine. So here's the unsigned 16-bit integer view of the three-dimensional texture. And you can kind of see it going up here exactly as you would expect. Now, amusingly enough, it ends right at 65535. You may wonder why that is. And that's because it just so happens that the size we had picked was 256 by 256 by 32, I believe. So 256 by 256, as you can see, comes out to exactly 65,536 values. If you start enumerating at 0, the last one you will enumerate is 65535. So every slice should have exactly this layout, and it does. Right. So that looks pretty conclusively like we're submitting that texture correctly, because when I'm looking at it in the debugger here, it looks exactly like what I would expect it to look like. So that's reassuring. The next question would be, well, what about the other two textures? Are they getting submitted correctly? And that's another question we should be able to answer by forcing structured art down the pipe. So let's take a look at what those look like. Here's what the other things we're sending are. We're sending lighting texel, and we're sending excuse me, a color value per light. So what I'm going to do here is I'm going to go and say, all right, from, you know, the light index will go through all of the values that are in this array, and I'm going to set them. So pnext dot p, pnext dot next, and C. Okay. So I'm just going to set the next pointer and the C pointer both to L. And I guess technically, to be extra sure, I'm going to go ahead and say that since there's only 4096, I'm going to set these so they run at 4096 plus L. And my reasoning for that is just to make sure that these two arrays aren't the same. Now, I feel like there's almost no chance that these things would end up overwriting each other or overlapping in some way, because I just don't see how that would happen in the code. But again, the point with structured art is to make it so that when you see a particular pattern, you can verify that it's exactly what you think it should have been, right? And so one of the things that we probably will need to do when we get a little further down here is we didn't have enough values to set all of these planes to be equal to the right thing. So what we probably should do is take whatever the z is and like bias the z, the value that we stick in here, by the z value times some increment, so we can verify that the slices are what we think they are as well, right? So, okay, so taking a look here, what we want to do is set the vec3 p value here. What I'm going to do for that is I'm going to set these to be equal to floating point values of L, 2.0 times L, and 3.0. Actually, let's do 4.0 times L, right? I could actually be a little bit easier on myself. Set them to 1,000 and 10,000 times L, let's say, or 100. Something like that. And this way, when we stuff those values, we will get something predictable in each channel that we can now verify in the actual application. Oops. And so now if I run the lighting comp, I should be able to do a pause and capture frame. When I capture the frame, I should now be able to take a look at all of those values. And in here, if I look at the fragment shader, you can see I've got the lookup sampler, depth sampler, texture sampler. Problem is, I want to actually look at some other ones here. And what's happened is you can see that even though those the textures I'm curious about, P next and C and stuff here, I can't actually verify those because even though they're here, like here they are, this is them, I can't actually get them because the compiler for the shader has optimized them out. Because here's where we were doing those texel fetches, and unfortunately, since we're no longer doing texel fetches from them, we can't actually get them. So that's not a really huge deal or anything because we don't need to debug those quite yet. So let's put that aside for the moment, and let's just go ahead and see why this isn't working. So if you take a look at what's going on here, I'm fetching a light eye using a texel fetch into this thing called lookup sampler, right? And lookup sampler is the sampler that's supposed to be getting our voxel values out. Now, when we pass a voxel lookup value into the lookup sampler, we're expecting to get out the numbers that are those monotonic increasing numbers, 0, 1, 2, 3, 4, 5, 6, 7, right? And what you can see here is when we get our use light values and stuff and such, we're expecting to reset these values. And you know what I'm going to do? I'm going to move this out so we can still see the red fringe. Right? Okay. So if I switch now, you can see the red fringe, which lets me know that my voxel testing is actually still working. And it means that these values, at least as far as we can tell, are within proper bounds, right? So Vox X, Y, and Z are all between 0.56 and 0.32 for the Z, right? And so what we would expect is when we get a texel fetch in here, we would expect the values coming back from texel fetch to be exactly those monotonically increasing values. So what we should be seeing, if we set all of the colors here, we should be seeing these light up in progressively brighter shades of gray. So just start at black at the min corner of the voxel and get progressively brighter as it goes up through any given slice. And each slice should be the same. So we should see no variance based on the Z height. Like looking at this, for example, we should see, if this were working properly, it's not. If this were working properly, we should see black at the min corner, white at the max corner, and no difference depending on the Z. So it should be completely uniformly colored up and down, but it should go from black like here to white like here, right? That's what we should be seeing. Instead, we're seeing no variance at all. So what we're seeing is as if the texel fetch is always coming back with nothing. Now, this exactly matches the bug we were seeing. So that is not surprising, right? This is what we would expect to see based on what we were seeing before. But it's still not what we would expect to see based on the code. So we obviously just don't understand something about this. And this is not, again, this is exactly why I hate GPU programming. It's because even basic simple stuff is almost impossible to get right, because even when you write something that's a trivial line of code that would, you've seen us do this on Handmade here a million times, we never have any problem getting this working in a reasonable amount of time. All we're doing is trying to floor a value, right? And then look it up in an array. That alone takes hours of debugging work on GPUs. It sucks, right? It's absolutely a miserable debugging experience. You always get it working eventually, but it takes like 10 times or 100 times even longer than it does on a CPU. Now, if you're a really good graphics programmer and you spend all your time doing graphics programming, I do not do that. But if you are, you end up trying to work around these things and you develop a lot more techniques for it, right? So it's not as bad as I'm making it seem, because if I were someone who was just on graphics engines all day, I would probably have a better approach to it, right? And things would go more smoothly. But they still don't ever go particularly smoothly, and they're particularly bad for anyone who's a generalist, such as myself, who just wants to do very simple stuff. I mean, even though it looks somewhat complicated to walk a linked list off of a voxel, these days that is not, I mean, a back-end graphics programmer on a main game engine would not hear that and go, wow, you're really, off in the deep end there. It's like, no, that's, this is not something that they would, I think, bat an eyelash at. So anyway, so what we want to know here is what's going on with this weird sort of situation here. What I would like to do is I would like to do a divide here of these values, so I can just verify vox p real quick. So if I take vox p, again, I'm going to sort of get a lot of this stuff out of here now. I'm going to take vox p, and I'm going to say that use light c equals vox p, and then I'm going to take each of these and divide them by their respective indexing values, right? So what I'm going to try to do here is basically turn the color into the voxel address, right? So we can just see what's going on there. Oh, sorry. Forgot to announce that variable. All right. So what you can see here is a color-coded version of the lookup. And it looks pretty reasonable to me, right? If we look at what we're getting here, as far as what the color values are being output, it's more or less what I would expect. It's getting towards black over here, with the blue value indicating Z. So as we go up higher, that blue gets stronger, right? As we go down, the blue gets weaker. As we get up towards this corner, right? So, so red is running this way, green is running that way, and blue is running like this. So that looks like a pretty stable lookup into the voxel, right? Those values look like what I would expect. Those are the floating point values. We are flooring those to get voxel indices. So what I'd like to do now is, again, switch to looking at this after the flooring, now that I know that that's right. And again, what you can see that I'm doing here is I'm literally just employing the most basic black box debugging techniques, because that's all I can do, to see which step of the process is going awry, right? So now, unless I've made some kind of an error, we are now looking at the actual output of the integerized values, right? Because we've floored them, and now we've taken a continuous value that's running across those dimensions, and I've truncated them. And you can sort of see it. It's a little bit hard to see because we've got a lot of gradations. But if, for example, you take the large step, the one that's only 32 gradations, the one that's 256 gradations, you can't really see because obviously that's a very fine level of gradation. But what you can see is here on the way up in the Z values, you can see there's little bands there, right? That weren't there before. And those bands are the truncation to 32 levels. So it's not, instead of the normal 256 levels that it was getting before, it's getting 32 levels, and you can see the banding there. Again, looks like a pretty stable voxel lookup, right? Looks like a pretty reasonable thing. Okay, so once we have that voxel lookup and we know what's going on there, here is the texel fetch that actually attempts to get a value out of here. And for some reason, and I don't know what that reason is, we are unable apparently to get the actual those values to come out to something meaningful. I don't know why. So now let's try to do that. I'm pretty sure I've validated what I think the inputs are to this thing. Voxi is what I think it should be going in. I'm going to have to look at textile fetch again to make sure that I'm not missing some subtlety of this API that you know we need to know that we don't know and we're doing wrong. Like I believe it takes an integer pixel coordinate to look up into the texels. I should say texel coordinate, and not a floating point value. So that's why I'm passing an integer in. I believe that integer to be correct, and I believe it to run the correct bounds of the voxel. So moving here to setting useLight, I'm setting the useLight red parameter. Actually, let's set one that we're not setting below. So the red parameter will now just be set based on whether we're outside the bounds. The green parameter will be set based on whatever comes back from light I. And here where we're actually doing this and getting the 65535 divide out here, I would expect this to give me green values that vary in a pattern, again, going along the, going from black at the bottom left corner to bright green in the upper right. So bottom left black, upper right green, right? And, you know, let me just verify that this is the case by casting that as well to a float. So we, you know, upconvert the light I to a float. I feel like that's, you know, what we should be getting here. And let's take a look. So you can see we're still getting black. So getting an integer out of this thing just does not seem to be working. And what I don't really know is why. So when we call textile fetch, let's just find out what that's supposed to be doing. Here I am in the OpenGL specification, and I'm looking at textile fetch. So here's textile fetch. You can see that like the one that is relevant to us would be this one here, where it's a sampler that takes a three-dimensional vector and a LOD value. Again, we don't have any MIP maps, so we're passing a LOD value of 0 here because we just want to look up into the basic texture that we submitted. We didn't submit any lower resolution versions. Here where we say use integer coordinate P to look up a single textile from sampler, the array layer comes from the last component of P. For array forms, we're not using array forms. The level of detail LOD if present is described in sections, you know, blah, 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 textile fetches, and scale factor and level of detail. We don't care about that because we're not doing anything fancy with that. What we don't know here is how this really returns things, unfortunately, because it's not really giving us much information there. So I think probably what we would need to do is look up uSampler and see what's going on with that somewhere. Hopefully we can get more information about uSampler somewhere and verify what that, because that's what we've defined, and we would like to make sure that that's actually correct. Wow. So they literally have no documentation for this whatsoever. Let's look in the general sampler section, and maybe they talk about that a little bit. So here we go. Where would that be? Texture functions. All right, so let's see. Automatic load details computed, blah, blah, blah. Texture data can be stored with GL. It's single precision, unsigned normalized integer, unsigned integer, or signed integer data. Texture lookup functions are provided that can return the result as floating point integer, unsigned integer, or signed integer, depending on the sampler type. Here's taken to use the right sampler for texture access. The following table lists the supported combinations of sampler types and texture internal formats. All right, so unsigned integer with an unsigned integer sampler type is what we should be using. Now, I believe that's what we did, right? here is the submission for our texture. It's a 3D texture, and we requested it to be stored unsigned in there. I don't know if this needs to be like unsigned integer or something like this. I guess we could take a look just to make sure. But that's only like how we're submitting it. So I feel like that shouldn't really even matter what we're doing there. Oops. But you never know with OpenGL. You never know. So it looks like that's not even documented in here. So yeah, I don't see any other options for that. So it looks like that's the only thing that could be happening there. I guess one problem we may be running into, and I don't really know, is I don't know whether we're asking for the proper versions of OpenGL. It may be that uSampler isn't really supported in this version of OpenGL or other things like that. Why we are not getting an error, I don't know. But that's sort of something that's kind of worrisome. So, you know, I don't know if this is really an acceptable thing, and maybe we shouldn't be trying to sample unsigned integers. Maybe we should still be trying to specify floating point values or something like this, and then convert them back. I'm not sure. But again, those are just some thoughts that are running through my mind. I would like to know when uSampler was introduced, and I don't really know how to determine that. I don't know if this really says. So I'm not sure exactly when that came in. Here's the 3.3 specification. And uSampler is in there. So in theory, we should be okay. I don't know. So the next question I have is, when I look up one of these, what is the value supposed to come back as, right? When I call textfetch, does it talk at all about what the value is supposed to come back as and what format, right? And the answer appears to be no. Let's see. So in the predictable of the G in the return for gvec is used as a placeholder for nothing I or U, making your return type of vec for I vec for or U vec for. In these cases, the sampler argument type also starts with G, indicating the same substitution done on the return type. It is either a single precision floating point, single signed integer, or unsigned integer sampler, matching the basic type of the return type as described above. So I think it should be giving us an unsigned integer, right? I mean, that is what we would expect here. From a uSampler 3D, I think it should be giving us an unsigned integer value back. Right? I think that should be giving us a UVec3. That's my guess anyway. And so if I run this, I shouldn't get any errors, right? Yeah. So this is giving us back a uint, but for some reason that uint appears to be like always 0 or something. I don't know because I can't see any output from it. So what I'm trying to figure out here is how could I get some information about what is coming back from Texel Fetch. I verified that these values are values that should work, right? I mean, I looked at them. They are 0 to 255 and 0 to 32. They're exactly what I think they should be. So they seem like they should be valid ways to look up into this texture. Yet when I look up into this texture, I always get 0 back, right? I know that the texture doesn't have zeros in it. I looked at what the texture has in it, and they're not zeros. And so I really just have no idea why it refuses to take a sample from this texture. I don't know. I don't know why it's unable to give me back a value here. I guess one question I sort of have is it possible that the shader itself needs to have something slightly different specified for it when the binding occurs? Doesn't seem likely to me that that would be the case. But like, you know, if there was something in the actual submission of this that meant that you had to do something different when you were binding it, right? But I just don't see why that would be, because you're only binding like a simple name, right? You're just binding like a uniform. And I don't really see... I mean, here's the code where that happens, right? And you can see it kind of getting the sampler IDs just by calling get uniform location. And it doesn't seem like that would ever cause a problem. Like, you know, it's this. There'd be no real reason for them to change how you were specifying samplers just because one was unsigned versus signed. It seems like it would always be GL uniform. So I really don't know why it thinks that's a problem. I couldn't say. But yeah, point being, we definitely know we have one. The question is just why can't we get that lookup? So it seems like that's our, you know, that may be almost the entirety of our problem. Because that would explain basically all of the failure we're seeing. If we can never get a lookup from our volume texture, we can never get the first link in our lookup chain, so therefore we can never look at the light values, and the game is over before it's even started. So that's what we're left with, is figuring out how that could be, right? Why can we not Texel fetch from this, you know... Why can we not Texel fetch from this volume texture that we know has the values in it that we think it does? Why do we not get any results when we try to do it, right? Now, maybe there's something else we could do here. I mean... I could try doing something slightly different, like maybe if I believe the divide to be a little bit weird, I could just do something like this so that I can still see some semblance of something going on in the green channel. I don't think that's going to change anything, right? Yeah. So that, yeah, I'm pretty sure that at this point, this Texel fetch is just failing. I don't have any idea why it would fail. There's no indication of why it would fail. It's not giving me any errors of any kind. It doesn't think that the shader code is bad. It just doesn't seem to want to actually do the work it's supposed to do to correctly access this value. I assume it understands the fact that this should be an integer value because it's not complaining about the fact that I'm passing an integer. If I was to pass a float, I would think that it would give me an error. And it does. So all of that is operating as we expect. So that's not unusual. Where's my... There it is. Yeah, you know, it's thinking it is exactly what it is. So that's even verifiable. And so the only question is, like, when it goes to call this thing, why is it unable to look up a valid value? Now, I suppose I'm being slightly presumptuous in the fact that I don't actually know. I mean, I would have assumed that the red channel was the channel where things come out. I guess I don't know. I should be getting a UVec3 from it. I mean, I shouldn't be getting a UVec3 from it. It's only got one element in it, right? It only has a single value. So I should only be getting a single value out of it, right? But what I assume it will do, as most TextLFX functions do, is they always return a 4-element vector, regardless of what you put in them. So I'm assuming that what light-eye actually is in this case is a 4-element vector. What I can do here is I could do something where we just say, okay, let's take a look at every possible value that comes out of this thing, and see if they're all 0, right? See if any of them are accurate or not. And I mean, I'm pretty sure they're all 0, but you know, we can, again, I'm just randomly trying to think of anything to try here. So if I randomly try the red channel, I should get exactly the same thing as I got before. If I randomly try the, and again, just to make sure, if I was to set light eye here, if I was to set the R channel to, like, you know, 300,000, I should get, you know, a half bright red. Of course, it's an integer, so you don't do that, but what is the problem? What did I do? Oh, do I need to specify that it's an unsigned value? Or I guess maybe the right way to do that would be to say uint. Yeah, so, you know, that's a green value, just like I would expect. And if I set it to 6,000... Oh, no, you know what? I forgot, this isn't dividing that way anymore. So let's actually change this back to my 65535. There we go. So that's green. And that's dimmer green. And I don't think there's much else to say about that, right? That's obviously working correctly. So if I was to start looking at the other channels here, get rid of that stuffing. Here's me looking at just the green channel. Nothing. Here's me looking at the blue channel. Nothing. Here's me looking at the alpha channel. So the alpha channel, for some reason, is coming back as a high value? Even before I've submitted the texture? So I guess the alpha channel defaults to 1. I mean, does it default to 0001 essentially in a texture or something like this? Like, why would that be coming out as bright? I mean, it shouldn't. It should come out as 0 if what I'm getting back is 0, right? That seems nonsensical to me that it would be anything different. The R, G, and B values are all 0, but the A value is not. I'm sorry. Why is that the case? I have no idea. So yeah, I'm totally stumped on this. I have no idea why this would be the case. It looks like this is just straight up fucking failing. Oops, I'm not supposed to swear on the stream yet. It looks like this is just straight up failing. And there's no particular reason why. You know, we got no errors. We verified that the values that we're looking up are correct. We verified that the values we're passing in are correct. And yet we never get back a value other than 0001, essentially, or in this case 000065535, is what we get back from every single texture fetch that we issue, right? So what's the deal? What gives? You know, why can't it do a textile fetch into a 3D texture the way that it's supposed to? Anyone? Anyone from NVIDIA watching, excuse me, who wants to tell me why I can't textile fetch? So we can try an iSampler here as well. It should do the same thing, but you never know. At this point, we're just random. We're just, you know, doing random stuff. Same deal. We could try looking up with a UVec instead, right? I mean, I don't know. So it definitely wants an IVEC there. Excuse me. Implicit cast from int to uint. Where is the implicit cast? Oh, it's in this testing here. But that's okay, because this is not what this function wanted. So that's a valid value being passed in the format that it wants to the textile fetch call that matches the format of the texture as requested. And it simply returns 0 in all cases. I would like an explanation. We don't by any chance have any NVIDIA people in the stream, do we? Or OpenGL people? Anyone? Because this is the kind of thing that happens all the time, and I would love an explanation for it, right? Like, I would love to know what their recommendation is for how do you figure out what is going wrong here, because this is pretty obvious. You know what I'm saying? There's not a lot else in there that's really going on. Now I'm gonna try changing some stuff here. What if we like arbitrarily changed our OpenGL version number? I'm just curious. Implicit cast from UVec3 to IVec3. Okay. Now, for some reason, that wasn't giving an error before. Now, that, granted, was just something I recently changed, but that's all right. All right, so no change. So even if I bump the OpenGL version number up to the most latest one, well, I don't know if that's the latest one, but it's a very recent one. No change. So it doesn't look like it has something to do with that, as far as I can tell. This is just straight up fail, and I have no idea why. So it doesn't seem to be a problem of like, hey, you can't do this or that or whatever, right? So I'm not sure what's going on there. One of the persons suggested on the chat, like, hey, let's up our level of debug notifications. We could do that for sure. You can see here that we've got a debug callback. What I could do here instead is just look at them all. And the other thing I guess I could do is I could print them out. Right? So this should just stream all of the debug messages. And in fact, I could preface them with something. And this way, maybe the OpenGL driver, like in a more in a subtle way, was like telling us something that would help us here, and we just aren't seeing it because we weren't looking at all of its debug, right? Now it's kind of given us a giant stream of stuff here. Let me see if I can get a bigger view of this, but because it's kind of behind my head right now. All right, so here's where we start. And the first thing it's telling us is buffer object 1 bound to GL buffer arb. Usage hint is GL static draw. We'll use video memory as a source for buffer object operations. So these are all just things telling me where this will go. Like, okay, it's just telling me that these things will go in video memory. And it looks like that's the only thing it's telling me. Basically, every frame it tells me that something's going to go in video memory. But it looks like that's it. It didn't say a single other thing at all. So as far as the driver is concerned, it has nothing to tell us, right? All right. Someone says that there was a Stack Overflow on why TextLFetch always returns 0 for a 1D single channel texture. Third comment, and they said sorry for Stack Overflow. Stack Overflow is fine if the person who writes the comment actually knows what they're talking about. The problem with Stack Overflow is a lot of times the comments are wrong, and then you end up getting like misled by something. That's the only problem with Stack Overflow. When Stack Overflow is right, that's good, you know? For some reason, I cannot open the browser on my Linux machine here because I think it's putting the browser window on a different desktop, and I can't seem to convince it to use this desktop. Oh, Linux. Yeah, I think that is what it's doing. Let's try Firefox. All right, Firefox seems to work, so we'll try that. Okay, so if I copy this link, Why is textile fetch always returning 0 for a 1D single channel texture? And they said third comment. It turns out that I also need geotext parameter, geotexture 1D, geotexture max level 0 to get it to work. The texture filtering mode can be left to default. Okay, if that's correct, though, that's really messed up because we're doing a textile fetch, not a texture read. So it should be reading only from the LOD level that we specified, right? If that was correct, that would be really, really erroneous behavior. Not that that's surprising, right? But just to be clear about this, so what we're doing here, right? Oops. What we're doing here is specifically a textile fetch. And a textile fetch does not use the LOD computation at all, right? Textile fetch takes the LOD as the third parameter. So filtering is not applied during a texture fetch. And it does not compute a bitmap, right? So there should be absolutely no cases where anything like that is occurring. So if that was actually the case, if this actually did fix it, that would be hugely messed up. But, you know, that doesn't mean it's not true because this is OpenGL and anything's on the table, right? But anyway, let's take a look here. All right. So what we're about to do, we're going to take that suggestion. What we're about to do is apply the code that would fix a problem if you were getting black back when you were sampling a texture using regular texture filtering and you had bitmaps turned on, but you were sampling using a thing that actually used the bitmaps and you had not specified them, right? We are not doing that, so that should not be occurring in any way. But here is the GL text image 3D call. And you can see, I believe we actually do specify this here. You can see us specifying it for other things, right? Like min filter, mag filter, wrap S&T, and so on. We specify a bunch of that stuff. I don't think we ever specify max LOD anywhere. Yeah, we don't. So anyway, if I come back down here, first thing I'm going to do is I'm going to try turning off filtering entirely. And again, filtering should never have been applied, right? That should not have been happening. But, you know, whatever. So we're going to start by turning off filtering entirely and putting clamp to edge on. Okay, we're not setting the max LOD yet, which was the suggestion, so we'll do that in a separate step. And also I should verify, because we were sort of fussing with the shader there, and I don't want to accidentally not have the right thing in here. So you can see us here saying, all right, here's the voxel lookup. We look it up into the texture. We get back a UVec4. We're using the R channel of the UVec4 to set the green channel. And then we're leaving it alone, so that should be fine. So I'm setting it so that it's never supposed to use LODs for minification and magnification. It's not supposed to bitmap at all. We get nothing. Here I will set the max LOD level. Max LOD level, what that does is if filtering was on, which is now not, it says don't ever use anything above a specific LOD level. So if I set it to 0, did I spell that wrong? GL texture max LOD. So it must not be defined in the base set, I guess. I can also set min LOD as well if we wanted to, right? And what that's saying is like, and we'll just set max by itself first, but what those are saying is when you go to compute which MIP level to look from, I want you to clamp the values between min and max. So that way, like, let's say that I still wanted MIP mapping to occur, so I was going to leave filtering on, but I only had, you know, 2 MIP map levels or something. So I wanted to make sure it would just stop after it went, you know, to like MIP level 1 or something, and not ever choose MIP level 2 because there is no MIP level 2 or something like that. So that's what min and max LOD allows you to do. That's all that is. So it looks like that's not defined in the base level OpenGL, I guess. So I'll just grab them. It's no big deal. There they are. So now we've got those in there if we want to play with them. And again, if this works, that's majorly busted, but I don't think it's actually gonna. Yeah, and it didn't. That would work in the case, again, where filtering was actually applied. Oh, wait. No, nope. We haven't really tested it yet. Let's run that test again. We've got to set it to text 3D. All right, so let's try turning the filter off first. See how that goes. So basically, I have no idea why that's the case. Texel fetch is not supposed to apply any filtering. Am I wrong about this? I kind of want a... I mean, it's Texel fetch. It is never supposed to filter anything. Turning the filter on and off should do absolutely nothing. It performs a lookup of a single Texel. What's it gonna filter? How do you filter a single Texel value? You don't have anything to blend it with. I don't know what to say. That seems completely nuts to me. We don't have to set min-max LOD because turning filter off was sufficient, and that's the more reasonable thing to do there, I think. But that's ridiculous. Like, why would that be happening? But anyway, like I say, in Stack Overflow, no problem, as long as they give you the right answer. And that was, I mean, that was a good suggestion from Stack Overflow, even though I'm not using exactly what they said to do. But they were suggesting that somehow it was getting filtered. I don't know how it was getting filtered. I would love an OpenGL person to tell me what that was supposed to be. Because if you're doing a Texel fetch, why is it applying filtering? It's explicitly never supposed to apply filtering if you're fetching a Texel. That's why it's called Texel fetch. Texture, that call, that applies filtering. This does not. Anyway, I'll turn off filtering on all of these because that same bug would happen again with the Texel fetch. So what about our other Texel fetch? We have a depth Texel fetch that we do. Should we be worried about that one? Are we getting incorrect results in other places because of this as well? Like, I don't know. It's a little disquieting, right? All right, well, now we're actually getting the lookups that we expected. As messed up as that might be. And, like, is that specified somewhere? Because it better be. if they just arbitrarily make it so that it returns black if you don't turn off filtering, even though filtering is not applied, I do not know what to say. Here's the GL specification. So here's the texture stuff that's in here. Coordinate wrapping and textile selection. I don't know if this overtly discusses textile fetch in here, which is a problem. Because I don't know, well, let me see if fetch ever really talks about it. So this is talking about buffer textures, which aren't really the same thing. But I'm just looking to see if there's any like hint. Effects of completeness on texture application. Texture lookup and texture fetch operations performed in shaders are affected by completeness of the texture being sampled as described in sections 11.135 and 15.2.1. Okay. This is talking about full texture fetches. It really just does not discuss fetches. So it looks like I guess what I would say is this is, I guess, the paragraph that's causing the problem. A texture is said to be complete if all the image arrays and texture parameters required to utilize the texture for texture application are consistently defined. The definition of completeness varies depending on texture detail and type. For 1, 2, and 3-dimensional and 1 or 2-dimensional textures, texture bitmap complete if all the following hold true. So this is probably the problem, right? It's probably the case that even though textile fetch does not apply filtering, it says that if the texture is not complete, it returns 001, right? So it seems like it behooves us to literally specify all of this stuff about the texture. I don't even know. According to that, it seems like we would actually want to do these as well. That makes absolutely no sense to me. But that that seems like the paragraph that's the problem, because technically, what does it say about filtering in here? Using the preceding definition, the texture is complete unless any of the following is held true. The internal form of the texture is integer. Wait, but that means an integer texture can never be complete? Using the preceding condition, a texture is complete unless any of the following conditions hold true. The internal form of the texture is integer. Oh, and either... here we go. And either... the nice grammar there, and either the magnification filter is not nearest, or the minification filter is nearest or nearest mipmap linear. Nearest mipmap nearest. So actually, never mind. We don't need these. That is what was screwing us, that one line in the spec. In a how long is this specification? How many pages? 758. So an operation that easily could complete, that's just a access into an array, failed and caused us like 3 hours of debugging time, because even though no filtering was requested, the spec says that you have to set the mode to nearest for an integer texture, even if you never call the filtering function. Why do I program GPUs? I should go work at a bank. Of course, they need to program GPUs now to do Bitcoin mining. Anyway, absolutely abhorrent. Everyone should be fired. And I would have fired them, but of course I'm not in charge. So all right. Hey, we can execute the array lookup now that we set a bunch of random crap that doesn't affect the array lookup. Happy birthday. All right, so now that we can actually look this up, we can go back to our texel function. And so actually, so in this case, the Stack Overflow information was actually technically wrong. But that's okay because it gave us like a hint about something to check, and we tried some other things that I happen to know I should also check, and those worked. So that's good. So Stack Overflow actually gave us a win there, if indirectly. And one should give credit where credit is due. So, all right, back to our story. Our texel fetch is now magically returning the correct values because of some completely unrelated, unnecessary code that occurred somewhere else. Now that we actually have those values coming back, we should be able to actually start processing our lighting elements now, which is pretty effing exciting. So let's go back and actually see if these values are now operating correctly. All right. So if we take a look, I'm starting to think that maybe we want all of these to be integer values instead of floating point values, and then we'll just convert them to floating point values in the shader. So what I'm going to do here is I'm going to make a little a little bit of a schmootsy smoo here and say that because we're sampling these as integer textures, I'd like to submit them all as integer textures. So maybe what I'll do here is say like, okay, this lighting textile value that has the next parameter there, and we've got this position. You know, maybe we encode the position. Well, actually, now I think about that, that's probably not necessary. But this next parameter here, that really needs to be specified as an F32 so that it'll be homogeneous. That's really all I want, is it for me to be homogeneous, right? So let's start by making that be the case. So when we get an L value here that's coming in, I'm just going to cast it to an F32. We know that it's never more than 16 bits wide. It could go up to 24 bits wide and it would be fine. So that's all good. We don't have a problem there. We can just do that cast. And it should cast in and out, no problem. So that's all good. We should be able to inspect these values now and see that they're actually correct. But in order to do that, we have to get them to actually compile into the shaders. So in order to get them to actually compile into the shaders, what I'm going to do is now that we've verified that our volume texture is at least somewhat correct, I'm going to go ahead and get rid of the part where we actually nerf the volume texture, and I'm going to let the volume texture actually take on the values that it should have. So when we start here, what we should see now is we should be able to figure out a way to visualize what values in our voxel are actually filled and which ones aren't, right? So when we're setting these lookup values here where we pack it, index into the lookup value, we should now be able to, right, and, you know, one second. So if you take a look at this, this is if I'm stuffing values with the predictable stuff. If I now actually change it so that we're keeping our values the same, the problem is we're going to get mostly black because we don't have many values that are particularly high. What I can go in here and do, though, is say, like, all right, I know we have values that range roughly from 0 to 1,000 or somewhere in there. Let me divide by a much lower number so that I should be able to see some squares in here that actually have information in them. And so you can kind of see here that occurring, right, where we're looking up into the voxel and getting some green in there, right, where these lights actually are. So, okay, that's all well and good. That's everyone's fine with that and happy and dancing around jubilant like a little monkey on a chain. All right. So now that we know that we're actually looking up into the voxel and we can actually see things that are coming out in the voxel, we can start to get rid of this code a little bit here and say, okay, let's take the fetch value that we actually get out of here and actually start using it again like we were trying to use it before as a IVEC, right? And see if we can actually or as an integer, I should say, and see if we can actually make that part work. So if we were to cast the red channel of this thing to an integer, and then we were to go ahead and actually start using it for some lookup purposes, here we go with that. If we come in here and we grab out a light eye, instead of using the light p next stuff, I'm not going to actually do that. After the textile fetches, I'm just going to use whatever this light color was here that we stuffed in, and we're going to use that light color, right? Now I'm going to do exactly what this was saying here to do, which is I'm just going to stuff pure green in there. In fact, I'll switch it to pure blue for now. We were using green before. I'm going to switch it to pure blue. Anywhere that it did find a light value, we want to make blue, and anywhere that it didn't find a light value, we want to not make blue. What was the problem? Semicolon, go. Off we go. And so that's what we expect to see. There's all the places where we actually had lighting elements sitting around, and that's totally fine. So now we come through here, and we textile fetch ourselves some values off of those integers. And so now what we should do is actually try to see what those are. So I'm going to actually keep the light C color here. I'm not going to loop over the various lights that may have been there. I'm just going to let it do one of those and see what we get. And so what we get here is we can kind of see we have some varying colors of red. I don't know if that's what we would expect. I think it is, because I remember correctly, yeah, we set those to particularly ludicrous values here. They're just going to be 4096 plus L. Should that be varying values of red? So it's a U32, so it's going to be interpreted as RGBA. Yeah. So I actually feel like there should have been maybe some green and blue in there, though. And it doesn't look like there was. So that's a little odd. I'm going to go ahead and stuff this value with, again, structured art just by itself, just to make sure that I'm getting what I expect out of here from a compact color. So what I'm going to do is I'm going to specify in here, I'm going to specify something like 4488 FF, right? So here I've got something that, again, in RGBA order. Of course, I don't remember what we specified this as being, so maybe I should go actually verify that first. But, you know, so here's the lighting C. This is specified as storing an RGBA 8 internal and RGBA direct down. So what I would expect, yeah, is the first byte. Again, this is Intel Little Endian, so this OX format here is, again, going to be read from the bottom forward. So it's going to be FF is the R, 88 is the G, and 44 is the B. So we should be getting kind of an orangish tan color in here. Hopefully, that's the goal anyway. That's bright, you know, has bright red channel, halfway green channel, and yeah, there's our tan. So that's what we would expect. All right, so those values seem to be reading out correctly as well. What I can do here is, again, just make sure that they're writing out in order here. This will give me definitively varying shades of red, and it does, so I'm okay with that. The 4096 must just have wrapped in an inconvenient way. Had some low bits in green that just got truncated or something like that. Doesn't matter. All right, so anyway, there's us verifying that those values were actually coming out somewhat correctly. Unfortunately, this stuff here with the p-values and that sort of thing is going to be harder to verify, but what we can do is use the p-values as a color if we wanted to, and verify that those are getting looked up correctly. And so what we could do there is say, like, all right, maybe we just take something here to see whether these values are getting stored the way that we think they're getting stored. So again, if I were to set this value to something predictable, and I'll set it to basically the same value that we were setting it to before, more or less, but this time in floating point. What I should be able to do is come over to the shader here. And in the lookup sampler part of the code where we do this, what I could do is say, all right, when we look up this light P next stuff, if I set this instead of from the light color, if I set it to the light P, what I should be able to see now is that that RGB value is coming out as we would expect it to come out. And it does look like it more or less is. So that's good news as well. So this loop should now be functional. If we were passing down correct values, we should be able to do something with it that's useful, such as summing up the lighting or doing, you know, who knows what. So what we want to do here is come up with some kind of a way that we can sample our lighting values in the while loop and create the actual while loop that walks through them. And so if we wanted to do that, let's just start with the basics. First of all, let's actually go back and not put nerf values in there. Let's put the real values in there. And what we're going to do here is we're going to say, okay, while the lighting index is not equal to 0, we're going to loop through here, right, and use the next parameter as we go. So we're kind of moving through the next parameters as we go. What we're going to do here is say, all right, when we do our light P next and do our textile fetch out of here, we're going to get the next value and the position of the light. And that's, you know, something we'll use for our lighting calculation later. We're also going to get the lighting index of the next light to look at, and that will keep us going in our while loop. Eventually that should return 0, and then we'll exit out of the loop. The light color will come presumably from here. And for now, we can just leave it like that and just see whether this works at all, because we don't know whether it will or not. It certainly looks like it's working. And not only does it look like it's working, but it looks like we're actually getting the colors we would expect out of our lights here, right, as these point samplers. Now, we're not actually computing any lighting from them. We're just setting the light directly, and we're not even handling it if we do get multiple light sources in a region. We're not really getting anything useful from that, so that's not as good, but that's okay, because we don't actually, we haven't actually tried to get this to work in, you know, any kind of sane way yet. All right, so the first thing I would say is, looking at the density of that lighting sampling, it does look like the lighting grid is too dense. and I don't really want it to be that dense because it's just going to cause us to have to do way too many lookups to gather the lighting samples that we want. So the first thing I'm going to do here is I'm going to go ahead and drop this down a bit. Maybe, a much sparser grid would be a better idea, so that because we're really not going to take that many lighting samples. So what I'd like to do is drop this down. Maybe we'll do 64 by 64 or something like this, just so there's a lot less data in the voxels, right? So I'm just cutting that down to something more coarse, right? So now you can kind of see the size of these things is considerably less small than it was. And that's more what I was going for here, because I don't want to be in a position where I'm doing a tremendous amount of sort of scatter gather. That may be too much. I don't know. I'm going to, for now, again, I think just drop it down even just a little more. So I'm going to drop it down to, to a 32 by 32, and let that do its thing. So those are some bigger light values there, some bigger, voxel lookup areas there, which is what I wanted. And one of the things that you can see is that our lighting sampling is not dense enough to cover all of the space with actual light, right? And that's not great. We want to make sure that we have enough lighting samples in an area to fill all of our voxels, and we're not seeing that happen. Now, I don't know why that's happening necessarily. There could be two reasons that that's happening. One reason is that we're just not putting enough lighting elements in enough places, and so that is obviously one reason why that could occur. The other reason why that could occur is we just have a bug in how we're filling the voxel, right? We could have a bug where we're just not placing it. So I don't know yet which one of those two it is. It's not super important that we do know at the moment, but you can kind of see, what's going on there for the time. Now, the interesting thing about this, right, is this inside the shader where we're doing our light walking. We can actually do something a little more sophisticated here if we wanted to. What we can do is we can actually walk a region around the voxel, so we can actually use an offset here. If we wanted to. So for example, once we floor this voxel I here, what we can do is we could actually include in here a ability to do this sample multiple times on voxels in a lot of different directions, right? So we can, if we want to, broaden, right, the sort of search, if you will, to look at neighboring texels. So instead of just sampling just one texel, we can sample the texels in like a grid around us, for example, or anything like that. So in order to do that, what I think I'm going to do here is I think I'm going to pull this out into a function, this thing right here, that's going to just compute the light for one of these. So if we take a look at this fragment code here, if I just introduce a function to the fragment code where I'm just like, okay, here is a thing that returns a vec3, which is like sample voxel light or something, or maybe like something that does, maybe something like this, some voxel light, and returns a vec4, and I want it to take an ivec3, which is the position to sample at, and it's going to return me, a sampled lighting result, right? Really wish we had indentation here. Should probably break these out into separate files, but I'm too lazy to do so at the moment. So what I want to do here is basically sum up how many of these we've gotten with like a weighting value, right? So what I want to do is say, okay, we're going to return a vec4 result here. The result's going to start at 0. I'm going to grab the light I. I don't care about this fringing right now. This is something actually that probably would just stay down here if we were going to do that test in the future, right? and that's fine. But what I want to do here is say, okay, so I've got this summation here where I'm going to do some voxel light, and I want to basically take all of this stuff where we do, you know, the textile fetch and all that stuff. I'm going to do all that, and I'm going to sum up the values as they come in. I'm going to sum up the RGBs, and I'm going to put in the alpha channel, I'm just going to put a value that's indicative of how much how much actual content I summed up. And we don't really care about that right now, but we will care about that eventually to normalize. And actually, even right now, we kind of want to normalize that sum, right? Because we're sort of summing over a loop. We want to normalize it down. So what I'm going to do here is, again, I'm just going to do a very simple, I'm going to take use light C. I'm going to make that equal to, well, actually, I guess I'll do something slightly different there. I'm going to call this sum voxel light thing. I'm going to call that, and I'm going to get back a light sum value that's a vec4. I don't know why I actually called it a vec4. I was getting into shader land there. So I'm going to call it a v4 rather. And what I want to do here is when I pass this voxel I value, I'm expecting a sum to come back. What I want to do is I want to compute the lighting value by taking the light sums RGB and dividing it by the light sums A, right? Now the problem with that is the light sums A may be 0. Like there may have been nothing in there, and then I would divide by 0. I'd have 0 in there, but I'd divide by 0 as well. And so in that case, that's less good, obviously. So what I kind of want to do in this situation is say, like, all right, only if the light sum A is greater than 0 do I want to do anything with it. If I can't find anything there, then I'm just going to set it to 0 and not do anything at all, right? I'm just going to assume there's no lighting. So that's the basic idea. Presumably we've got some syntax errors and stuff. Incompatible types in initialization. Okay, yeah, I agree with that. Undefined variable vox I agree with that as well. And now we should get the same results we got before, which is what we wanted. Now, the other thing that I can do here is, since I want to, start summing up these values, if I want to sample multiple voxels around the region, what I can do is I can actually just kind of, oops, I don't really want to cut and paste that quite yet. What I can do here is sum all of the voxel sums. I can actually do several of these, right? So I can make something like this, and I can sample as many voxels in the neighborhood of this voxel as I want to, right? I can do something like this. Where I'd be sampling essentially a cross pattern. Oops. Right, so that's sampling sort of the left, right, up, down, and back, front textiles. I can, it gets more expensive as you go. Like every time I do this, right, it's going to get more and more expensive. But it's basically, starts to spread the light out, right? So I can do those sums of the vox. I can do those sums and query a bunch of things around the voxel. I can also do this if I want to in the entire cube, right? I could do the whole thing. So I could do like a pattern more like this. So start at -1, -1, -1, and then go to 0, 1, right? Move to 0. So that's basically like starting at -1, -1, go to 0, 1, move up 1, right? And this would just, it's getting ridiculous, right? Obviously. But you could imagine sampling an entire cube of voxels, which is what I'm doing here. And this is just the ridiculousness of having way too much flops at your disposal, right? Like so. So this samples like everything. And we don't need to resample 0, 0, 0 because we already did it. Up here with this one. So that one could go away, but all the rest of them would stay. And that would sample the entire ridiculous cube, right? And what's particularly bizarre about that, obviously, is, it still runs at 60 frames a second, It's just nuts how much flops you got in there on these modern chips, right? It's just nuts. They're packed with an incredible amount of computing power. Remember, this is running per pixel. So it's actually querying all of those lights in the voxel per pixel, right? Which is completely ridiculous. And probably we will move away from doing anything like that, but there it is. And you saw you can do it. So if you want to actually do each individual lighting thing there, you can, and no one can stop you. On a modern GPU, you've actually got that kind of power, which is nuts. So anyway, if we are to do something like this, where we sum up all of the lighting in sort of those regions like that, what we don't know here we still have a lot of issues with this, obviously. There's a ton of stuff that we're going to have to do here, but let's just push this a little bit further. Since we got it working today, let's just start playing with it so you can kind of get a feel for what's going on here. All right, so first of all, that lighting value is getting used as a raw lighting value here, right? And we don't actually need it to be used as a raw lighting unit value here because we actually do have what the surface color should have been coming in here, the surface reflect color. So if we want to, we can actually modulate the incoming lighting value by the surface reflect color rather than just hard setting it, right? So we can do something like this, where we modulate instead, and in that case, what we will get is an actual version of the game running that just has the lighting happening, right? And so what you can see here is now, if I am to move this around, I can reset the lighting in any particular area, and we actually get something that starts to look like the lighting's actually being used. But we definitely haven't done anything that we would want to use in a game. It's certainly not good. So what we want to do now is start to fix some of that. Okay, so first of all, we're getting a bunch of information here and we're not using it. We have a light p-value, which is where the light is supposed to be, where this emission value is coming from. And then we have a light C value, which is the color of the light, and we're just using it. But what we did not do is we did not actually see whether or not our particular surface, which we do know what it is, right? Because we have sent down, as part of this, we do know, for example, the world normal and the world position in question. So we know where we are and we know what direction our surface is pointing. So we should be able to actually sample this lighting in a more reasonable way. So for example, if we know where the light value is in the world, where we specify this light P here, what we can do is look at the difference between those two. So we can take the distance to the light source and say, well, we've got the world P that we're at, and we've got the light P, right? I guess we call it the delta. That's how far, that's the vector along which we would have to travel to get to that light source, right? And then we also could say, well, okay, if we know the delta to the light source, we also know how far away we are, right? Because we can take, for example, the distance squared to the light source, we could easily find by just squaring the value, the length of the delta, right? So if we do a length squared of delta, we could figure out how far away we are. I think we have that in here somewhere, right? Do we have a length squared? Yeah. So we'd already defined a length squared macro for ourselves, so we can find out what the length squared is to the light source, right? So that would be 0 when we're right on it, and that would be, as we get further away from the light source, that will go down, right? So what we could do there is say, well, all right, very simple attenuation to start with. Let's say that as we get further away from this thing, we're going to attenuate it more, right? And then I'm going to sum up only the attenuation values. And what this is going to do is, actually, I don't really want to call it attenuation because I'm not really doing lighting attenuation here. What I actually want to do is contribution blending, right? So all I'm really going to do here is say, all right, I want to weight the lighting values based on how close I am to each one. So that if I have multiple lighting values that I pick up, I'm going to use the ones that I'm closest to more strongly than the ones that I'm further away from, right? So what I'm going to do here is say the contribution value of this thing is going to be a function of the distance squared away from it, let's say. So I'll take 1.0 minus the distance squared. So the contribution will be full if the distance squared is 0, so I'm right on it. And it will dwindle away as we get lower, right? I don't want it to ever go below 0. So in this case, I'm also going to clamp it, which I think we also have a function for. So I'm going to clamp it here between 0 and 1 so that it can't go below, right? And that's all. So now, if we are fortunate enough to pick up more than one lighting sample in the voxel, we will blend between them, right? Now, the problem with this is that it'll only work if we actually have enough voxel coverage. And what you can kind of see here is we just don't have dense enough lighting sampling, or we're screwing up how we're placing them in our voxels. I'm not exactly sure which, but one or the other is true. And so, again, what I can do is just to sort of get this basically working is I can just, again, drop that voxel resolution down a little bit more to pick up more samples in the voxel. That way we have more lighting samples per voxel, and we can blend more values together, right? And what you can see as I get down to a level where I'm actually picking up enough of my samples is you're actually starting to see real, like, smooth lighting start to materialize, right? Which is kind of cool. Now, we're not quite there yet, and the reason is because our samples, again, are just still not, we're not grabbing enough samples in any individual voxel to make this work, right? Because our lighting solution is just a little too sparse, is the problem. But you can see where I'm going with this, right? Or hopefully you can see where I'm going with this. Oh, the guy like hopped on top and he was outside the voxel region there for a second, right? But yeah, hopefully you can see where I'm going with this. You can start to see how this lighting would materialize as we go, right? You can start to see how the lighting samples would get blended together to produce a sort of smooth lighting solution in the end, as we could sort of start to figure out how to make this work, how to get enough samples into the smoothly blending part of things to make it work. And again, all this is trying to do, this step that we're adding here, all we're trying to do is make something that takes lighting samples we've distributed throughout the world and smush them together into a way that's smoothly varying across the world, right? That's all we're trying to do. Okay. So we've got a lot of stuff we've got to work on there. I also don't know, we're in O2 mode, right? Yeah. So yeah, we've got a lot of work to do there, and it's unclear exactly how we're going to get there. So we've got a bunch of stuff we're going to do to try and get past that. I'm curious, we can keep setting the voxel down and putting more stress on the GPU, but getting more blend samples in there. I'm just curious what happens as we drop it down. There we go. We finally slowed it down. Right, just a little bit. And so again, what you can see there is it continues to get sort of a smoother and less blocky, less patchy sort of solution to the lighting. And it starts to be kind of nice, right? Like, you know, we've got a long ways to go, but you can see how that's starting to create more of a nice lighting effect. And, you know, most of our problem here is we're just not getting much transmission of the lighting. So there's a bunch of stuff we're going to need to do, but it's like you can kind of see how having a gather step at the end really sort of puts things into a nice, like, really sort of puts things into a sort of more pleasing result, right? So what I'd like to do is go ahead and tomorrow, when we start in this, start thinking about how we're going to flood this region with samples properly, so that maybe something at about this level of granularity of gather will work properly. And that's going to take a little bit of work on our part, but I think that's roughly what we would like to do, right? So we'll start playing with that some more. That's going to be it. I'll go ahead and go to questions now. Bessel has asked why no indentation on the shader code. The reason there's no indentation on the shader code is because it's in a string, right? Because we didn't. So we probably should, because we're doing enough work with shaders at this point. We probably should pull the shaders out into separate files, right? But we didn't do that. And so as a result, these are just strings, and 4Coder by default treats strings as non-code data, which does make sense because most of the time they aren't. What would be nice is if magically you could somehow hint to 4Coder, maybe by picking a specific thing here, like that, you know, or whatever. I guess you can't really quite do that because it's too long, but something where you could pass a little hint to 4Coder like, hey, this is code. Could you just run the indenter as you normally would on the blocks below you, right? But that's kind of a very special purpose thing. It's obvious why it doesn't support it. Have you tried CUDA? Do you think it's a reasonable way to do GPU programming? AMD is trying to get a CUDA-compatible compiler so it could be usable on both vendors soon. I have not tried CUDA, no. I mean, my thoughts on that are very simple, really. To summarize, the question is more, will we ever get there, right? Because there's a lot of barriers to it. My thoughts on that is that GPU programming should not be GPU programming. It should just be CPU programming, right? It should be exactly the same. A GPU should functionally just have an ISA that you compile code to a machine-level specification that specifies everything, right? And it should be extremely direct, right? A texel fetch call, there should be no concept of anything having to do with anything involving completeness of textures or any of that stuff. There should be a layout of textures, and that layout is mandated. It is a memory layout format. A texel fetch should be just an array access with guaranteed semantics about how that memory is fetched, and that should be the end of it. You should be able to write assembly language code that gets executed on the GPU, just like you do on a CPU, and it should be 100% specified. There should be absolutely no API at all, right? It should just be like the Intel architecture reference manual. That should be it. And each of the instructions should say exactly what it does in terms of memory. That's what it should be, right? And we're really far from being able to have that, but that's what it should be. Because that's the only thing that provides a reliable, debuggable, like easy to understand programming interface for experts, right? 4-bit Lightning, if I remember correctly, we tried to use pound include in multi-line strings for the shader code, but that didn't actually work. I think the reason was because we were trying to remain compatible with Visual Studio 2013, so it doesn't really have any way to do that. I think there was a way if you go, we actually are on Visual Studio 2017 now. I think there is a way to make it work there, but I don't really want to require that either way. I remember actually Neil was trying to figure out, or was it Neil? No, you know what? It wasn't Neil. It was Martins, I think maybe. Martins was trying to figure out how to get it to work and send some suggestions, but they didn't work. And I think, if I remember correctly, the reason they didn't work was because it wasn't a late enough version of the compiler. I've just started a project and I'm working through the setup on day 2. You had it set up Patblit on WM Paint to alternate black and white. If I made no mistakes, then it doesn't work on Windows 10. I'm instead getting all white, and if I drag the window around, the new part of the window becomes black. Do you know if there are any caveats for Windows 10 I should be worried about? There should be no problems with that on Windows 10. That doesn't sound right to me. It sounds like you have a problem with your paint handling. Like maybe you're not calling begin and end paint, or maybe you didn't set up the window handle right or something. But that should, no, I don't think that's Windows 10. I think you've got a bug somewhere. Like the fact that if you drag the window around, the new part of the window becomes black, suggests to me that you just have a paint bug. Like maybe you're not actually doing the paint all the time or something like that. Nixie, do you have any suggestions on how to start going about voxelizing more complex 3D meshes rather than simpler geometric shapes? Break them up into simpler geometric version, allowed meshes first. Should each mesh be pre-voxelized, or do you need to recalculate relative to the worldview position and possibly distance from the camera? So you're asking about are you saying like, so you're on the GPU? Like on the GPU, you want to send down a mesh to the GPU and have the GPU voxelize it, Neil? Is that a correct interpretation of what you wanted to have happen, or am I misunderstanding you? Like you want the GPU to voxelize a mesh into something you can then use on the GPU, like inside that frame? Is that what you mean? Or is that a misunderstanding of the question? Sorry, I'm just waiting a second. I wanted to give Neil a chance to. Nixie, not necessarily doing it on the GPU, but to provide what the GPU needs to do this sort of lighting with more complex meshes. Okay. So you're kind of just talking about like the more general question of like voxelization in general. So unfortunately, here's what I can say. I have a great deal of experience voxelizing meshes on the CPU side. I have no experience voxelizing meshes on the GPU side. So what I could tell you is I can tell you about how voxelization goes on the CPU side, and then speculate a little bit on the GPU side and give you some references. So on the CPU side for voxelizing meshes, I actually shipped a commercial product that does that. So Granny has a mesh voxelizer built into it, actually. And what it did that for was for one of the things that Granny has a really good one of, even though I don't think anyone uses it, is it has a thing that will take a high-res model and transfer properties from the high-res model onto a more lower resolution model. And it does this extremely quickly. At the time when I shipped it, it was common to wait several minutes for this to happen, and ours ran in like 1.5 seconds for such a thing, usually, or even sometimes sub-second timings. So it was extremely fast relative to the common way this was done. And the reason for that was because I used voxels to accelerate the process, because they're kind of the natural thing you would use for this. Anyway, so in order to do that, what I had to do is voxelize meshes. I had to voxelize the low-res mesh and the high-res mesh so I could find correspondences between them using the voxels as a search region. The way that I was doing that was I wanted my voxelizations to be perfect, right? So there's different ways you can go about voxelizing things, and some are based on... And which way you voxelize a mesh depends on how you wish that mesh to be used. I can give a very specific example in two-dimensional voxelization so that you can understand what I mean by this. And it's important to understand which one of these two you want, and which one of these two you want is dependent entirely on what you expect to be doing with the voxel when you put it into use. So we talked about rasterization, right? And we wrote a rasterizer on for Handmade Hero, for our software renderer. And one of the things that we talked about during that, and remember, a rasterizer and a voxelizer are the same thing, right? A rasterizer is fundamentally a thing that figures out which pixels on a 2D grid are covered by a triangle. A voxelizer is a thing that figures out which voxels in a 3D grid are covered by whatever thing is you're voxelizing, but a triangle, let's say. So in the case of a mesh, a triangle. So remember, when we did our rasterization, what we were doing was we were checking to see whether the centers of things were covered, right? And so we would consider this pixel, for example, to be in when we were rasterizing because its center was here, even though there's a segment of it that was out. We would not consider this to be in even though there is a segment of it that is in, right? And that's typical of a rasterizer, and the reason that's typical of a rasterizer is because a rasterizer expects there is then another triangle that comes in here and fills this thing, right? But there's another way to look at rasterization. A conservative rasterizer is one that wants to know every pixel touched by a triangle. And so in that case, what would happen is you would want to know, even though like this is considered out for a traditional rasterizer, I would want to consider this in, because I would want to consider it in whenever it touched at all, right? And so what we're looking for there is knowledge of whether or not the triangle passes through the rectangle, not just whether or not the center is included in the rectangle. So, what I did for the voxelizer, because what I wanted was a voxelizer that was actually 100% precise. I wanted something that would know exactly what part of every triangle was in exactly which voxel, right? That's what I was actually trying to do. And so in order to do that, what I would do is I'd say, okay, in, my voxel, what I would do is say, I know where my starting point is going to be. So I can classify my starting point into one of my voxels, and then I know, where the other points are as well, right? I don't know where they might be, but let's say they're in here. So I know 3 of the squares that are filled, certainly, right? I know that this square is filled, this square is filled, and this square is filled. I know that they are touched by my triangle. And so now, really, the problem that I have is I have to figure out how I would walk how I would walk along the voxel in order to get everywhere that might have been filled by the triangle. And the way that I actually did this was just go like, okay, well, let's break it into slices first. So the first thing I would do is I would clip the triangle to figure out, I'd say, well, all right, here is a starting point. Let's clip the triangle to this Z slice, right? And figure out how much of what part of the triangle occupies this Z slice. That turns it into a 2D problem, right? Where I then have, something that looks like a clipped triangle, right? Like maybe the triangle passes out of the Z slice here. That I can now voxelize as a triangle. I would then do the exact same thing for the next dimension down. I would say, all right, let's now clip the triangle to this bucket, and I would get this piece, and then I would run between the min and the max, slicing it again to figure out exactly what part of the triangle was clipped to just this square, and then I would slice it again to figure out just which one was this square, and I would keep slicing, right? And so that was, that scheme is sort of a successive triangle dicing scheme. That is for when you need to know exactly which piece of a triangle is in exactly which piece of a voxel, and you don't want to miss anything. You want it to be exact everywhere, right? And so that was good for the application I was using. However, that's probably overkill for a lot of voxel operations, right? If it's something that can be more sloppy, and it's something that you're trying to run at a much higher frame rate, like I said, this was something that could take a few seconds to work because it's an artistic transfer process. You're basically like, all right, bake this mesh into this mesh. It's not something that has to run frame to frame. So I wanted to err on the side of accuracy rather than on the side of speed because we were already also so much faster than anything else out there. It wasn't really necessary to push that boundary. And a few seconds to do a mesh transfer, in any case, was way better than anyone would have needed anyways. So, if you were trying to do voxelization in some other way, right? If you're trying to do voxelization where you would like to do something cleaner, less code, run faster, whatever, I think there's a lot of ways you could approach this problem, right? So let's take a dumb way of approaching this problem just to give an example of how you might do it. So let's suppose what I wanted to do was I just wanted to exploit parallelism here to fill this thing up, right? And I just, I'm going to do something simple. So if I had a triangle, let's suppose that I looked at that triangle and I said, what voxels are the corners of the triangle in, right? Well, if I got back the answer that all of them are in this particular one, I'd be done. That's the voxelization of the triangle, right? If I get back 3 different ones, what I could do is like bisect my triangle or trisect my triangle, right? I could do something like, like that, and run it again, right? Or I could do something where I bisect it a little more fairly, like maybe I do something like the Triforce, let's say. So I bisect each of these, and I turn this into 4 triangles. And then I ask the same question. If you kept doing that, you would eventually get to triangles that were only in 1 voxel, and you'd be done, right? So one very simple way to voxelize a mesh, if you just don't want to think about it much, is just to dice your triangles smaller and smaller and smaller until they fit into a single voxel each, and then that is the voxel that they are in, right? This, I believe, is typically called Reyes rasterizer. Is that right? Can we get a definition there? Here we go. Blah 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 blah. That's not a definition. Yeah, so here you go. The basic Reyes pipeline is following steps. Bound. Calculate the bounding volume of each geometric primitive. Split. Split large primitives into smaller diceable primitives. Dice. Converse the primitive into a grid of micropolygons, each approximately the size of a pixel. Shade. Calculate lighting and shading at each micropolygon grid. Bust the grid into individual micropolygons, each of which is bound and check visibility. Hide. Right? So this is effectively what I'm advocating, right? It's how Pixar's renderer worked up until the modern day, I think, actually. I know they did a big rewrite or are in the middle of one now. I think they were Reyes for a very, very long time. I don't actually know when it was replaced, but it was like, you know, Toy Story at least was still using Reyes rendering. I suspect even probably up to like The Incredibles they may have been still using Reyes rendering. I don't know. I don't work at Pixar, so I have no idea. But that is one model of approaching this that has the benefit of simplicity and parallelism. There's not really much thought involved. It's just like you dice and repeat, like you're just filling up queues of diceable things and going. So something like that might be appropriate for what you're trying to do. Again, if you just want something simple, because rasterizers can get very complicated when you start to think about how they work. At voxelizers even more so because of the third dimension that's involved there. That's one way to just write one to just get it working, right? If you want to be more fancy about how you voxelize, I think probably what you're looking at is like, probably I'd start crawling references out here, out in the weeds, and I'd see who's up to what at this point. Because GPU voxelization is a current topic. And there's a lot of papers that you can look at on there. And so if you want to know, more about that, you can probably get, let's see here. I mean, you can read all this NVIDIA stuff, but I'm assuming they'd have some references here. And so 2013 is probably not the most recent thing, but I mean, you can start here. This looks like a pretty good little overview too, right? I mean, that's something. And I would kind of go through some of these people who do voxelization for lighting. You can see how they are doing it, right? I don't know where in this paper they would talk about that, but I would expect that they would. Oh, this is interesting. So they're using like successive renders from different directions to generate the voxel. So yeah, I mean, I don't know because this isn't my area of research. Like I said, the only time I ever really did voxelization, I was looking for highly accurate CPU side voxelization, and that scheme I don't think would be appropriate for this kind of use. I would probably look at that paper. I would crawl the references out. So on Sightseer for it, I don't know how to get to just the Sightseer link, unfortunately. But I'd crawl the references out from that maybe, and look at how people are generally talking about doing GPU voxelization today in some papers. Maybe you've already done that and found them not to be particularly illuminating, and if that's the case, I apologize, but that's probably what I would do. But does that help at all, Neil? I don't know. So I don't know if that helps answer your question or if it doesn't really help answer the question. I don't know if there was something specific that you wanted to know about voxelization that I didn't really touch on. But using an REYES or REYES system is probably the simplest thing to get working, I would say, because it's pretty easy to write something that just goes, look, either this triangle's in a voxel or it's not. If it's in a voxel, then that's it. You know, I'm done. If it's not in a voxel, I just have to write something that like subdivides it. And if you can actually do something fairly smart there too, you can just divide the triangle based on its longest axis too, or something, right? Or its longest side, you know? So you could do something that kind of, you know, if you have long skinny triangles, it would be smart enough to divide the two long sides and, you know, break it that way or something rather than breaking it up along the shorter side or something, right? So you can increasingly be smarter about how you subdivide too. And so that's also something that I would say, you know, might be worth looking into. Even just doing the dumb approach, just doing it relatively smart is probably fine. Where you go from there, it's like once you get that working, then you can start thinking about, well, okay, you know, that is probably pretty dumb. It's probably not what you want to do if you're trying to get something to run real time and really fast and whatever. So when you actually go to voxelize meshes in the you know, in a high performance scenario, you probably are going to want to start doing the research there and finding some people who've tried to figure out how to get the highest throughput voxelization they can on the GPU side of things. And that's probably not a subdivision based process, but I don't know. Because like I said, I haven't really done that reading. All right. Anyway, good luck with that, Neil. Hopefully you're able to get something working there. I'm going to go ahead and quit out of this here and close down the stream for the day. Thank you, everyone, for joining me for an episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along with our series at home, you can always pre-order the game on handmadehero.org. And it comes with a source code. So if you want to, you know, fiddle around with it and try your own experiments with the code base, like if you want to play around with these shaders and do stuff like that, you can go ahead and do so. We also have a forum site you can go to ask questions, and a Patreon page you can go to if you want to support the video series. We have a schedule bot that tweets the schedule at you, and an episode guide that allows you to catch up on previous episodes. My understanding is it is broken right now. I don't know why, but it only goes up to day 405, even though we're a little bit past that. So it's only really for the archival purposes at the moment. I think there's some kind of server stuff that people have been working on. I don't run this site. This is a different site. It's Handmade Network. It runs a bunch of sort of projects, and they're doing some stuff on it. I don't know. So it's not quite up to date yet. It will be eventually. But it's not quite yet. So if you need to grab episodes from the very recent past, you want to go to the YouTube archive, which, of course, you can also get to by just going to youtube.com Handmade Hero Archive. And that channel has all of the videos on there up to date as well. So that's really all you should have to do. That's it for today. I will be back here tomorrow. When we will try to sort of start to bring our lighting stuff together a little bit more, because now we've got everything working, the building blocks are working that we need to, and we need to start thinking about how we're actually going to do our sampling and blurring and blending and that kind of stuff. And so now that we actually have something we can play around with, we can go ahead and look at that, and that's what we'll be doing tomorrow. Hopefully it will lead to something fruitful. Till then, have fun programming, everyone, and I'll see you on the internet. Take it easy, everybody.